Hello everyone, my name is Aanchal Jain and this video is the part of the final assignment of tall building design course from Skyfilabs. This is a 23-story building that will be designing. The live load is different for different sets of story, but the dead load of the building is same, that is 2 kN per meter square. For stories 1 to 8, the live load is 5 kN per meter square. For story 9 to 14, the live load is 4.5 kN per meter square. For story 15 to 19, the live load is 4 kN per meter square. For story 20 to 23, the live load is 3.5 kN per meter square. These properties can be applied by the concept of similar stories. Also, beams and columns are listed, each of having M40 concrete, HYSG 500, mild 250 rebar. We can use the auto select option so the software choose which is best for the building. These slabs having M40 concrete and 150 mm thick, we can use auto draw cladding option and cladding load is 0.2 kN per meter. For the build load, we can consider the parameters of the building constructed in background. Now we open the ETAP software for designing the building. Select the new model option from the file menu. Then select the Use in Build setting option as displayed. Then click on OK. In Uniform Grid option, choose the number of grid lines in both X and Y axis is 4 and set the spacing value in X direction 6 and in Y direction 6 meter. Then in Simple Story Data option, set the number of stories to 23 and both the typical and bottom story height to 3 meter. Now you need to define similar story option, so select Custom Story Data and click on Edit Story Data. To divide the story into similar sections, story 1 to 8 is similar, so select any story as master story and click on Yes. Then set the other story as similar to new master story. Now for next set of similar story, that is 9 to 14, select any of the story as master story, click on Yes, then select the other story as similar to new master story. For other similar section, that is 15 to 19, select the story 19 as master story. Four sets are already existed, then select the OK and select Grid Only option. Click on OK. For defining the material properties, go to the Define menu and select the material properties. Click on Add New Material. Select the region as India, material type as concrete, standard Indian and grade M40. Click on OK. Then click on OK again. Again click on Add New Material and this time change the material type as rebar and grade as HYSU grade 500. Click on OK. Then again click on Add New Material and select the grade as mild grade 250. Then click on OK button. Now the three materials have been defined. Click on OK. Now you have defined frame and slab section with these material. In the Define menu, select Section Properties and then Frame section. Click on Add New Property. And select the concrete rectangular option and give the property name as column 500 mm by 500. And change the material as M40 concrete. And change the dimensions to 500 inch. For the reinforcement property, select the modifier show rebar. Select the design type as column and longitudinal bar as HYSU 500 and confinement bar as mild 250. Click on OK. Then click on OK again. Now you need to define two more columns which have the same properties with different dimensions. Then click on Add Copy of Property. Change the section name as column 550 by 550 mm. Change the dimension. Click on Modify Show Rebar. Then click on OK. Again click on Add Copy of Property and give the property name as column 600 by 600 mm. And change the dimension also. Then click on Add New Property and select the Auto Select list. In this, give the property name as column auto select. and change the design type to concrete. Then select all the 3 columns, click on add and click on OK. For defining the beams of the section, click on add new property, click on concrete rectangular and select the property name as beam 500 mm to 300 mm and change the material to M40 and change the dimension respectively. For reinforcement property, click on modify showy bar. In design type, click on beam. Select longitudinal bar as HYSC 500, confinement bar as L250. And click on OK. Then click on OK again. Now you need to define 2 more columns which have the same properties with different dimensions. Then click on add copy of property and change the property name as beam 550 mm by 350 mm and change the dimension accordingly. Again, click on add copy of property and type the property name as beam 600 mm by 400 mm and change the dimensions accordingly. Then click on add new property and select as on auto select list and select the property name as beams auto select and design type as concrete. Then select the 3 beams, click on add, then click on OK. As beams and columns are defined, click on OK. To define the slab section, select the slab section frame from the define menu. Click on add new property. Type the property name as slab 150 and slab material as M40 and thickness 150 mm and click on OK. Then click on OK again. In the plan view, go to story 1, click on OK. Select the quick draw column option Change the column property to auto select column and select the desired area as displayed. Then click on Quick Draw Beam and select the property as Auto Select Beam. Then select the desired area. For defining the slab, click on Quick Draw Slab option and define the property as slab 150 and draw the slab. As we have clicked only one story, then this building is made only by one story. Now click on similar story option go to story 2, click on OK. Then click on Quick Draw Beams and Column option and select the property as Column Auto Select. Then select the desired area. Then go to Quick Draw Beams and select the beams which we have drawn. Then go to slab option and draw the slabs. As stories 1 to 8 is similar, then the story 1 to 8 is made. Now go to any of the story from 9 to 14, click on OK. Select the Quick Draw option and select the desired area as displayed. Then select the Quick Draw Beam and select the beams. Then select the Quick Draw Slab option Then go to any of these stories from 15 to 19, click on OK. Select the Quick Draw Column option and change the property as column auto select and select the desired area. Then click on to draw beams. Select the beams. Then click on to draw slab. Now go any of the story from 20 to 23. Click on OK. And select the desired area. Click on to draw column option and select the desired area. Then click on to draw beam. Then slab. The building is ready, almost. Now we have applied some loads to the building. For defining the loads in the building, since the dead load is same in the building, select the all story option. Then click on story 1 from the plan view. Click on OK. Select all these cells in the story 1 by click on select object option. Then click on assign menu, then shell loads, then uniform, and type the load name as that and load is 2 kN per meter square. Then click on apply. Then click on OK. Now define the lab load for different sets of story. Select the single story option. And select the slabs again. Go to assign menu, select the shell load, then uniform, and choose the load name as live, and the value of load is 5 kN per meter square. Click on apply, then click on OK. From the plan view, go to any of the story from the next set, that is 9 to 14. Click on OK. Then select the slabs. Go to Assign menu, Shell Loads, Uniform. As load type is live and load is 4.5 kN per meter square, then click on Apply, click on OK. Again, go to next set of story, that is 15 to 19. Click on OK and select the slabs. Then click on Assign menu, Shell Loads, Uniform, and the load value is 4 kN per meter square. Click on OK, click on Apply. Then go to next section of similar story, that is 20 to 23. Click on OK. Select the slabs. Go to Assign menu, Shell Loads, Uniform, and give the load value is 3.5 kN per meter square. Click on Apply, then click on OK. The dead and live load have been applied to all the buildings. Now you have to define the cladding load. Choose the single story option and select the exterior beams of the story 1 to 8. Now go to any of the story from 1 to 8. And select the exterior beams carefully. Go to Assign menu, Frame Load, Distributed Load, as load pattern name. Enter the uniform load is 0.2 kN per meter. Then click on Apply. Click on OK. Now go to next set of section of similar stories. Then select the exterior beams. Then go to Assign menu, Frame Loads, Distributed, as load 1 2, click on Apply, click on OK. Then go to another section of set of similar stories. Select the exterior beams. Then go to Assign menu, Frame loads, distributed, and the load value is 0.2 Newton per meter. Click on Apply, click on OK. Then go to another set of single story section. And select the exterior beams. Then click on Assign menu, Frame loads, distributed, and the load value is 0.2 Newton per meter. Click on Apply, then click on OK. Once you apply the load, now you have to remove the load from the upper story. Then go to the story 23, click on OK. Select the exterior beams. Then click on Assign, Frame loads, distributed, and click on Delete existing load. Click on Apply, then click on OK. Now go to the base of the building. Select the one story option. If the story options are not visible, then click on Display menu and under Form Shape. Then the story options are displayed and select one story option. Then click on Assign, Join and Restrain and change as fixed. Click on Apply. Select all the joints of the frame. Then click on Assign, Joints, Restraints, and change them to fixed. Click on OK. Go to Draw menu. Select the Auto Draw Cladding option. And click on OK. As processing takes place, it may take some time. Now we have to define the wind load. Select the Define menu and Load pattern. Type the load as wind. And select the IS code for wind load, that is IS 875-1987. Then click on Add new load. The wind load is added. Now click on Verify lateral load and change the values from the IS code 875-1987. Enter the wind speed as 33, terrain category 3, structure class C, risk coefficient 1, topographical factor 1. Then click on OK. Then click on OK again. With the plan view option selected, click on Elevation. Select the elevation side as A and click on OK. Select the All Story options and select all the claddings. Go to Assign menu, Shell Loads, then Wind Pressure Coefficient, and coefficient to 0.8. Then click on Apply and click on OK. Then click on Elevation View. Select B as elevation. Click on OK. Then select all the claddings. Go to Assign menu, Shell Loads, Wind Pressure Coefficient and S 0.8 coefficient. Click on Apply. Click on OK. Then click on Elevation as G. Then select all the claddings. Go to Assign menu, Shell Loads, Wind Pressure Coefficient and coefficient type as minus 0.25. Then click on Apply. Then click on apply, then OK. Now select the elevation side as C. Select all the claddings. Click on assign menu. Shell load wind pressure coefficient and minus 0.25 coefficient. Click on apply, then OK. Then click on elevation view as 1. Click on OK. Select all the claddings. Go to shell load, wind pressure coefficient as 0.8. And select the leeward or slide constant option. Then click on apply, click on OK. Then select all the claddings in the elevation view too. Three, and 4. Then go to assign menu, shell loads, wind pressure coefficient as 0.8. Click on leeward or slide constant. Click on apply. Then click on OK. As all the properties, sections and loads have been applied to the building model, now we have run and analyzed the model. Select the 3D view and select the use extruded view for frame. As processing takes place, the extruded view of the model as shown. Then go to analyze. Click on run analyze. Save the file where you want. You can check the analysis from the bottom bar. Once the analysis is complete, you can check the displacement value. After analyze, you will run the design. Click on design. Then click on concrete frame design. Then click on start design check. This process will also take some time. Once the analysis is complete, they show one notification that analysis and design section differ for 705 concrete frames. It means software used to auto-select column and beams from the list. In this, 705 frames are failed from the design. In 705 frames are changed to next higher section of beams and columns. Click on yes and software automatically run the analysis again. After processing is complete, there is no notification appeared and 3D view displays the longitudinal vein crossing. Thus, the design of the building is complete. Click on the project and summary report, which are also generated. This is the project report. Now, we have successfully designed tall building design using ETABS. Thank you.